Today we see about operational amplifier topic. So first we see about the definition of amplifiers. So amplifier is nothing but a electronic devices that increases the strength of the signal, whether it is voltage, current or power, using an external power supply. So the main purpose of amplifier is nothing but we are boosting the signals. That is, if you are having weak signal in input, that will be increasing or strengthening the signal in output side. So that is why we called as a boosting the signals amplifiers. So mainly we are using this amplifier is audio equipment, wireless communication and broadcasting side. So now we see about what is the applications of operation amplifiers. In this, simple amplifiers, summers, comparators, integrators, differentiators and analog to digital converters. In this side we are going to use operational amplifiers. So this operational amplifiers we simply called as having 741 IC. So IC means in integrated circuit. So totally we having 8 pins. So this is your symbol of IC. So totally 8 pins. In this diagram we see about 7 pins. So the plus and minus, that is pin number 2 and 3 is called as the input and pin number 6 is called as the output. And pin number 4 is a minus VC, that is voltage supply, and 7 is a plus VCC. So in this pin we are giving the power supply. So for IC purpose we are giving 5 volt and output we are going to take a pin number 6. So next we see the real look of your IC 741 operational amplifier. So totally 8 pins. Pin number 1 is offset null and second is inverting input. Third pin is non-inverting input. Pin number 4 is minus V and pin number 5 is offset null. Output pin is 6. Pin number 7 is V plus. Pin number 8 is no connections. There is no connection given to your pin number 8. Next we see about a golden rule for operational amplifier. There are 2 rules. The first rule is we just find whether it is negative feedback or not. Then second rule is we just see or we have to fix this voltage difference between the 2 input is 0. So that is a golden rule for operational amplifier. The next we see about a inverting amplifier. So simply the inverting means what you are giving to input signal, that will be opposite answer you are getting in output side. So if your signal is positive means in your output side you will get a negative. Okay, so that is your input signal is connected to pin number 2, that is negative terminal. So in this we are having input terminal V in, resistor and I in. Then next is called as a RF. It's nothing but a feedback resistor. That is nothing but the output is connected to again to your input. So we call as a feedback resistance. The equation for inverting amplifier is V out divided by Vn, that is equal to minus RF divided by R. So RF is called as a feedback resistant, R is called as a resistant and output voltage divided by input voltage. Next one is called as a non-inverting amplifier. The input signal is given to plus terminal. So whatever you are giving the input, the same output will be getting in your output side. So if your signal is plus means positive means the output signal is also positive. So the equation for non-inverting amplifier is V out divided by V in, that is equal to 1 plus RF divided by R. The next one is summing amplifier. So summing means we are going to add a more number of signals. So we are using a summing circuit. So in this we are using 3 voltage signals, 3 input signals that is given to your non-inverting terminal. That is inverting terminal. We are giving 3 input signals. So in output side we will get in the summing of input signals. So we see the equations. The next one is called as a difference circuit. So difference is nothing but subtract the signals. So that is the output signal is proportional to difference between two input signals. So your output side you are getting the difference of two input signals. Okay, so that's it. Thank you.